So here's what's going to be on the final. 40 multiple choice questions. Just like on this practice final, there's 40 questions. So similar, there's 40 multiple choice questions. And let me see. Hold on a second. And okay, you can use a sorry, I was just umming. 40 questions. You can use a calculator. Okay, so if you don't have a calculator, you cannot use your phone. Your phone can't be your calculator. So I know students will be like, I use my phone as a calculator, but your phone is also access to the internet and can give you all kinds of information. So you cannot use your phone. Okay, but you can use a calculator, and something like this, like a TI graphing calculator is fine, or just a little scientific calculator, or even just a little calculator that just will do basic calculations like addition and multiplication and whatnot. You can use that. Okay. I would prefer that you had like a little scientific calculator, and we do have those. So if you don't have one, okay, good. The Proctor will have one if you need to borrow one. So also from the Proctor, make sure you get scratch paper. Do not try to do these problems in your head. I know it's online. It will be right in your computer system like you've been doing your benchmarks this semester, but you need an access code from the Proctor like we did first semester. Okay, so please get scratch paper. Find a spot in the room where you're comfortable. If you get distracted, don't sit right by the door. Sit in the back, that sort of thing. Okay? Any questions on that?
No.
No. Okay. And then scratch paper and a pencil. So make sure you get that from the Proctor when you go in. Okay, so let's just go over some of these problems. Ileana, since you're here, I want to go over the ones you would like to go over first, and then I can kind of go over some of the other ones. So can you tell me in the chat box which ones you want to go over?
Yeah.
Okay, I'll give you a minute. Okay. Welcome, Nolan. We're just going over problems from the practice final. Type them in the chat box. Did you type yours? Oh, there they are. They just popped up. Okay, so let's start with those. Nolan, I'm going to give you a minute to type in your questions from the practice final that you'd like to go over. Okay, so 2, 4, 6, 13, 16, 18, 26, and 40. Okay, let's start with the problems you guys want to go over, and then we can come back and do some of the other ones. All right, let's do number 2. Find the surface area of the cone in terms of pi. And then I gave you the surface area formula. I will give you the formulas on the final too. It will be in the Canvas, like in the question, just like here. It will be in there. You have to know what the terms mean though, okay? So you need to know what R means and what L means. And then of course what R means here. So what does R mean here? What's R?
Radius?
Yeah, R is the radius. And what's L mean?
Length.
L actually in this formula is the slant height, okay, of a cone. It's the slant height. So this is the height. And the slant height is the height here on the cone surface. This is your slant height, okay? That's your L. So you have to know what that is. That's your slant height. If you're not given the slant height, could I figure it out with the information I have here?
Would you use the Pythagorean theorem?
Yes, good. So I'm going to go, since I have a triangle and I need to find my slant height, that's the height on the surface of my cone. That's why I call it a slant height, okay? I need to figure out that height. So I know this is 16, this is 12, and this is the diagonal of a triangle right here. So I'm going to go 16 squared plus 12 squared equals my slant height squared. All right, so I'm going to use a little calculator. What's 16 squared?
256.
256 plus 144 is your slant height squared. Now just do the math. 256 plus 144 is 400. Good. Now I want to square root it, and I don't care about the negative. It gives me a plus and a minus solution. I don't care about the negative solution because my length is not going to be negative. So I only care about the positive solution. So the square root of 400 is going to be 20. There, 20 centimeters. So now I have my slant height, right? So now I can plug everything in. The surface area, I'm going to take pi and multiply it by the radius, which is 12. And then I'm going to multiply it by the slant height. That's going to give me my lateral area. The slant height is 16, plus the area of the bottom of my cone, right? The bottom part of my cone is going to be pi, and then my radius is 12 squared. So just plug it all in. This is a calculation issue. It wants it in terms of pi, so I'm not going to multiply out pi as 3.14. I'm going to leave it. So 12 times 16 is 192. 192 times pi, plus 12 squared is 144 pi. So I have 192 pi's plus 144 pi's. That's 336 pi. And that is, oh, we have centimeters here, so I need to do centimeters squared. All right, so just make sure you understand what the slant height is. That's probably the hardest part about that one. All right, let's go to number 4. Number 4 is find the volume of the square pyramid shown below, round to the nearest tenth if necessary. All right, so we have the formula here. Volume is 1/3 base times height, big B meaning area of the base times the height, not little b. Okay, so we just plug it in. Volume is 1/3. I need the area of the base. Well, if it's a square pyramid, this side is 5, and if it's a square, this side's also 5. So what's the area of the base?
10 or 25?
25. 5 times 5 is 25. So the area of the base is 25. So 1/3 times 25, and that'll be meters squared, times the height. Well, the height of the pyramid, here's the problem. I'm given the slant height here. I'm not giving the height. So I need to figure it out. Just like back there I had to figure out the slant height, here I have to figure out the actual height. Drop a perpendicular, draw it over. Okay, so look, now I've made a little triangle inside here. I know the slant height is 12. I need to figure out my actual height here. This is a right angle. And if this is a square and I come over in the middle of my square, if this whole thing is 5, what's this piece right here?
2.5?
Yes, 2.5. Good. So here I have 2.5, 14.2, and the height. Now I can do Pythagorean theorem again. H squared, oh, that's an ugly H. Let's try that again. So I'm going to go H squared plus 2.5 squared equals 14.2 squared. And then solve. So let's just do the solving. 2.5 times 2.5 is 6.25. Welcome, Haley. And then so we've got h squared plus 6.25, and then I'm going to do 14.2 and square it. And I'm going to get 201.64. All right. Now to solve for h, I'm going to subtract off this from both sides. Just do the math here. And I'm going to get h squared is 201.64 minus 6.25. On a calculator, I just did that. So 195.39. Now I need to square root both sides to get h. You get a plus or minus solution, but I don't care about the minus solution. So I'm going to square root this, 195.39, and that's going to give me approximately, I'm going to round this, okay? My h is approximately 13.97. I'm going to go 13.98 because it's 9781. So 13.98, rounding to 2 decimal places just for now. So my height's about 14 is what it is. Now I'm going to plug this into my formula. I'm going to go, my volume is 1/3 the area of the base times the height, which is about 13.98. And let's go ahead and do the math. Multiply that by 25 and then divide it by 3 really. So I'm going to get approximately 116.48 or 0.5, 116.5. It's volume. This is meters, this is meters, and this is meters. So it's going to be meters cubed. All right. So the hard part is figuring out the height. You have to do Pythagorean theorem to figure out the height for number 4. So make sure you know how to do that. Any questions on that one?
No.
No? Okay. All right. Is that what the answer key gives? Because I'm doing these cold.
Yeah, I think so.
All right. Check me.
Check.
Check my work. Double check me. Okay. Let's go ahead and go to number 6. Nolan, you want 18, 20, and 22. I'm going to write 20.
Yes. Also, I wanted to point out that number 4 is kind of wrong because I was looking at the answer key, but I suck at the answer key to correct the problem, and I realized, oh, it's not the same. But when I kept trying to find this solution, I just kept going back to the same solution that I got, which was 110.75.
And the one we just did?
Yeah, number 4.
And you got 110. And what does the answer key give you?
Like 116 or something.
Yeah, that's what I did. You just see the problem we just worked? That's what we just got.
Yeah, that sucked because it was like wasn't like, didn't you have to do it like in the Pythagorean theorem to figure it out?
Yeah, we just did it. Were you watching it?
No, kind of got distracted working on the other problems.
Okay, Nolan. It's being recorded right now. I'm going to post the recording. I just did that one. We'll come back to it again if we have time at the end, okay?
My bad, sorry.
It's okay. Yeah, it's 116. Is that what the answer key gives? That's
Yes.
Yeah, 25.
okay. We just were, Nolan, draw a perpendicular, drop a perpendicular right here. And then you draw a little right here. So when you do your Pythagorean theorem to get your height for this problem, you have to do the whole Pythagorean. This is 14.2. This right here should be 2.5, and this is your height. So set up your Pythagorean theorem like that and solve for your height. Okay. If this is 5, half of it is 2.5. Right here, this is 2.5. Okay, so make sure you set it up like that. Okay, so let's go on to number 6. Let me see. Okay, so number 6 is scrolling down. Okay, find the slant height of the pyramid shown to the nearest 10. So the nice thing about number 6 is we just did number 4, which we had to find the slant height, and then we had to do all this other work. Number 6 is just the slant height, right? It's easier, correct?
Yeah.
So we just can go, okay, well, if that's 10, this is 5 across. So what is this little piece right here?
2.5?
Yeah, just like the other one. It happens to be 2.5 again for this particular problem. Okay, so 2.5. So Nolan, this is just like the other one, how we solve for the height. Except for instead of finding the height, we want the slant height here. So set up Pythagorean theorem. That doesn't even look like a 10. Sorry. This is 10. Set up Pythagorean theorem, 10 squared plus 2.5 squared. And sorry, my writing is getting uglier and uglier as we go on, equals your length squared. So solve. 10 squared is 100. What was 2.5 squared? Wasn't it 6.25?
Yeah.
Is your length squared. Sometimes after a minute, the pen gets tired and it does not let me write how I want to write. Hold up. Okay. Is the length squared. So length squared. Okay, so 100, so 106.25 is your length squared. Now to solve, what do I do to both sides?
Square root.
Square root. Square root 106.25. And I'm going to get an approximate.
10.3.
Yeah, just round to the nearest tenth. So 10.3. There you go. And that's the slant height. I wasn't asked to find the volume there, so we're done with that one. Okay, let's go on to number 13. Haley, I'm just doing the problems that are requested. So if you have specific problems you want me to do, please put them in the chat box and I'll go over those. Okay, let's go over number 13. Write the polynomial in standard form, then name the polynomial based on its degree and number of terms. Okay, let's first put it in standard form. Standard form means I start with my highest degree term and I go down. So which term would I start with here?
8x.
8x
Three.
cubed. Yes. Then what?
8x.
Then 8x. Then what?
Minus 9.
Good. Okay. Now I want to name the polynomial based on its degree and the number of terms. Okay. So let's look. How many terms do I have?
3.
3 terms. So it's a trinomial. Tri meaning 3. If 2 terms would be a binomial. Okay. Now based on its degree. So if I have a cube, it's a cubic. So it's going to be a cubic trinomial, meaning I name it based on its degree, the degree of the highest term. Okay. So if it was a square was the highest term, it would be quadratic. If it was a single term, like it was just 8x minus 9, this would be linear. Okay. So based on its highest degree, it's a cubic trinomial.
Okay.
So it should be pretty straightforward as long as you can break that down. All right, that's 13. Let's go to 16. The area of rectangular picture frame is given by that trinomial. What are the possible dimensions of the painting? Use factoring. So if you like to break this down, just so you can understand, we got a picture frame, right? We got dimensions. We got a length and a width, okay? So what are the possible dimensions of a painting? Well, the area in here is going to be x squared plus 2x plus, or sorry, not plus, minus 80. That's the area inside there, okay? I would like to know the possible dimensions of the painting, the length and the width. What was it before it became this? This times this gave me that. What is this times this? Well, I'm just undoing this. I'm unfoiling. What was it before it was that? Undo the foiling. So what we unfoiling is called factoring, okay? So I like to do the guess and check method. What that means is this term, when I foil, is the first terms. So this times this is your first term. So my only choices here for x squared, my choices are x times x, right? So I'm going to go x times x. So I always put my choices for this one over here. And then I take my choices for this one and I write it over here. What are the choices for negative 80? They go in the last terms. Well, my choices for negative 80 are quite large. But because I don't have a term there, I know negative 80 is going to add up to be 2. So what are the choices for negative 80 that could possibly add up to be 2? I know 80 is 8 times 10, right? 8 times 10.
Yeah.
And if I add 8 and 10, I do get 2, but only if one of them's negative. Well, I have negative 80, so I want one of them to be negative. Negative 8 times positive 10 gives me negative 80. Negative 8 plus 10 does give me 2. So there it is, negative 8 and positive 10. Now here's what I always do. I check. So I guessed, now I check. My inner term and my outer term need to add up to be 2x. So I make my little spaces here. I go, my inner term is negative 8x. And then I go like this. My outer terms are 10x. And I know they need to add up to be this. Does it? Negative 8x plus 10x is 2x. Ding, it works. This is correct. So what are the possible dimensions? I'm going to go, well, I put x minus 8 and x plus 10. I could say this is my length and this is my width, or I could switch them around. It doesn't matter. But those are my possible dimensions. All right. So that's 16. You want to do 18? Okay, we're okay with 17, factoring that one. Okay, let's do 18. Suppose the area of the square lawn is this. What is the length of one side of the lawn? So we want the length of one side. This says it's a square lawn. Square lawn means they have the exact same length. So it's a square lawn would be length times length. They're both the same. So this is going to be a perfect square trinomial. It's a perfect square. And I can always tell, this is how I can tell. My first term, is it a perfect square? Well, it is. It's 3x squared. Is my last term a perfect square? It is. It's 2 squared. Now, if I have ax squared plus something plus c squared, this middle term is going to be 2 times a times c. If it's a perfect square trinomial, that's the pattern. Well, is that middle term 2 times my a value, which is 3, times my c value, which is 2? Well, it is. 2 times 2 is 4. 4 times 3 is 12. Oh, it is. It works. This is a perfect square trinomial. Okay. Now, when it is that, this is how it factors. It factors like this. 3x plus 2 times 3x plus 2. Okay. The first term, and since this is positive, plus the second term, first term plus the second term. They have to be the same because it's a square. 3x plus 2 times 3x plus 2. Now let's say you didn't know it, you forgot about the patterns of the perfect square trinomials. You don't have to remember those patterns or memorize them. You really don't. Just factor it like you did number 17. Okay, number 17, if you factor that, you can use 2 methods. You can do the factoring by grouping method or the guess and check method. This has a term here. The first thing I would want to do here is factor out the largest, greatest common factor before I even factor. Let's check this. Does this have a greatest common factor? 9, 12, and 4. Let's see, 4 and 12 have something in common. 9 and 12 do, but 9 and 4 don't. So there's no greatest common factor. So here's how I do this one. I just unfoil it with guess and check. I go, the factors of 9x squared here would be, I know it's going to be x and x. So I'm going to go the factors of 9. I could go 9 and 1 or 3 and 3. The factors of 4 I write over here. I could go 1 and 4 or 2 and 2. Okay, so I want to figure out what's going to go here. Well, I know my first term, I'm just going to guess. I'm going to go, let's try 3 and 3. Okay, 3 and 3. And then for this, let's try, should we try 4 and 1 first or 2 and 2? Now here's a little trick. I'm going to go for 2 and 2, and this is why. Because it's a square lawn, and they should be the same. It should be the same term twice. So I know it's not 4 and 1 because it's a square lawn. Length and width are the same. So I'm going to go 2 and 2. Now it's positive, so I go positive, positive. Now check. 2 times 2 is 4. 3x and 3x is 9x squared. Check your middle term and make sure it adds up to be 12x. So I go like this. Inner term is 6x. Outer term is 6x. Do they add to be 12x? Yes, I've done it right. 3x plus 2 times 3x plus 2. So let's say you couldn't remember that perfect square trinomial deal. Factor it just like it's a regular factor problem. And then you can solve it. Okay, that's how you do that one. What's the factored form of this expression? This is right here. Oh, 19 wasn't a request. Oh, I'll just go over it real quick. Anytime you have a perfect square and a minus sign, you have the difference of perfect squares. You have a squared minus b squared factors into a minus b, a plus b. Now, if you FOIL this back out, you'll see why it's not a trinomial. Because when one's minus and one's plus, the middle term falls out. FOIL it. First terms gives you a squared. Inner terms, negative b times a is negative ab. Outer terms, a times b is positive ab. Last terms, negative b times b is negative b squared. And look, negative ab plus ab fall out, and you're left with a squared minus b squared. So when one's minus and one's positive, you just have two terms. That's what I have here. Recognize it. This is 5x squared minus 144 is a perfect squared. It's 12 squared. So I have 5x minus 12 times 5x plus 12. Okay, difference of perfect squares. All right, let's look at what's the next one we wanted? Number 20. Let's go over number 20. And 20.
I think somebody requested 17.
Oh, did I miss that? Oh, since it's not a square. Yeah, let's do 17 real quick. Okay, since it's not a square, I'm just factoring it like a trinomial. This is the hardest trinomial to factor. When I have a term here, I can't do the thing where this adds up to be this because that term throws me off. I have two choices. I can break it up where I do the factoring by grouping and I break up that middle term, or I can guess and check. I always like guess and check. So let's go ahead and do that. First thing before we start, is there a greatest common factor that I could pull out to make this easier? 8, 26, and 70 are all even, so at least 2 divides out. Is there anything bigger than 2? I'm not seeing anything bigger. Let's go ahead and pull out the 2. So if we factor out a 2, I'm left with 4y plus 13y minus 35. Okay, I pulled that 2 out. It's still part of this to be the final, but now we can just focus on this, and it's smaller. Okay, I need this to factor into 2 binomials. I know by unfoiling it, when I foil, I do my first terms, and I know this is my first term. It goes here and here. So I come over and I'm going to go, well, it's going to be y and y, but what will my number be? Well, the choices for 4 are 1 times 4 or 2 times 2. Now my last terms go here and here. This times this gives me my last term. Now my last term possibilities are factors of 35, negative specifically. So, I mean, you could do -1 and 35 or switch the negatives around. 7 times what? 5. 7 times 5. One's negative, one's positive, or flip them around. Any other factors for 35 you can think of? I think that's it.
Yeah.
Okay, so now we just have to make sure our inner term and our outer term add up to be 13y. Okay, if they do, then I've picked right. So now here comes the guessing part. Should we do 1 and 4 or should we do 2 and 2? Let's just go for it. What do we want to try?
2.
Should we try the 2 and 2? So we're going to try 2 and 2. This is our guess part. It might not work. It's our guess part. So let's try 2 and 2. Now we have to come over here and guess 1 and 35 or 7 and 5. Now, since I have such a small number 13, I'm not going to pick 35. That's going to throw my numbers really big. So I'm going to pick 7 and 5. Now, what order I put them in, I don't know yet. Let's not worry about the negative. Let's just put 7 and 5 here and see what we come up with. 7 times 2 is 14 y's. 5 times 2 is 10 y's. That's not going to give me 13 y's. Yeah. What if I flipped them? What if I did 5 here and 7 here? Well, this is our guess and check part, right? So let's go 5 here and 7 here. So this is going to give me 10 y's, and 2 and 7, 14 y's. That's not, nope. Nope. Okay, let's go ahead and leave my 5 and 7 and come back to these. Let's go. All right, let's try this again. Let's try. Okay, so let's try 1 and 4 or 4 and 1. I'm going to put it in red. So let's go 4 here and 1 here. So 5y, this will give me 5y. And 4 times 7, what is that? 28?
28.
No, let's switch and try 1 and 4 maybe. So let's go 1 here, 4 here. 5 and 4 is 20. 7 and 1 is 7. So 20 y's and 7 y's. That could give me 13 y's, but this guy has to be negative. 20 minus 7. So now I know what I want. I want negative 7 and I want positive 5. So that gives me 20. That gives me negative 7. 20 minus 7 gives me 13. And there's my factors, guys. That's it. So what are possible dimensions of the floor? You're going to have y plus 5 and then 4y minus 7. And then you have this 2 out here. So here's the thing. The possible dimensions for the floor, you could multiply because the floor is rectangular, you only have 2 dimensions. So multiply this back in. This could be 2y plus 10. So possible dimension would be 2y plus 10 times 4y minus 7. Or if you wanted to, you could multiply the 2 in here and not in here. You could also have y plus 5 times, this would be 8y minus 14. So either of these would be possible dimensions. Either of those would be valid answers. All right, guys? Okay, so that's number 17, 18. Let's see, did we do 20 already?
No.
Okay, let's look at 20. A large Amazon box has a volume given by that trinomial. What are the possible dimensions? We need to do factoring again, length, width, and height this time. 3 dimensions we need. Okay, so let's look at our trinomial. Before we start, greatest common factors. That's what we want to work on, greatest common factors. Can you guys pull out a greatest common factor here? How about, go ahead and look. Is there a term that they all have in common? There's not a coefficient, but what about a variable? Are we stumped?
Kind of.
What variable is in each term?
Oh, y?
Yeah, y. They have a y in common, right? So I can just go ahead and pull out a y. So let's go ahead and do that. If I pull a y out of each term, I'm left with y squared plus 4y minus 21. All right, so we've got a y in common. Now I've pulled out that y. That will be my extra factor. Now here, just go ahead and factor this. doing your factoring methods. This term goes here and here. Now I don't need to write out all the choices for this term because what are they? Y and Y, done. I do need to write out the choices for negative 21. But because there's no term here, I know specifically I want them to add up to be 4. So I know 21 is 7 times 3, correct? Could that possibly add up to be 4? If one was negative and one was positive, right? Well, 7 times negative 3 is negative 21. So I'm going to go plus 7 minus 3. Check your inner terms, 7y. Check your outer terms, negative 3y. Does that add up to be 4y? My middle term? It does. So there are my factors. Y plus 7, y minus 3. This y still exists. So there are your 3 dimensions. Y times y plus 7 times y minus 3. And you're done. All right, let's go to, what's our next one? 22 you want to look at? Okay, ball. Okay, so this is your typical ball thrown in the air problem where you have your velocity and whatnot. So let's go ahead and look at 22. So if a ball, you know what I always like to do with these, just to help me with it, I like to draw a little picture so I can get a little visual. So if I look at, hold on, just a second, my screen just froze. I'm giving it too much. Okay, while my screen is frozen, if you guys want to draw a little picture, what does that look like? I can't see the problem right now, but what does the ball thrown in the air look like? What kind of curve would it make? Is it going to make an upward parabola, a downward parabola? Is it going to be jiggly points? What's it going to be?
Upward.
Okay, so if you throw a ball into the air, is it going to make this shape or is it going to make this shape? And it comes back down.
And upward.
Is it going to look like this or like this?
Oh, downward.
Yes, yes. Okay, so if I'm throwing a ball into the air with a velocity, I'm standing here. I throw it up and then it's going to come back down, right? Okay. Its height in feet after t seconds is given by the function. So don't let the h and t confuse you. They're just your x and y renamed. Okay, time is usually your x, so this is your time, and your height is your y. So if I start by throwing a ball up, it's going to hit a max height and come down. How long does it take the ball to reach its max height? Max height is, look, it's going to be right here. Do you know what this is called on a parabola? What is that on the parabola? That middle point. It's called something with a V. Yes, Haley, it's the vertex. When they ask you max height, just think vertex. That's all I need is the vertex. That's it. So don't let the wording of these problems confuse you. Max height is just the vertex of your parabola. We know how to find vertex. Either you put it in vertex form, which takes a little while because you have to do the whole completing the square deal, or you just know that vertex is negative b over 2a. That is the x value of your vertex. That's the x value of your vertex. Then you plug it back in to get the y value of the vertex, or in this case, the h value. So this is your t and your h, right? T and h, okay? Or x and y. So negative b over 2a, let's look at our values. Our a, our b, and our c. This is in standard form already. So our a value is here, negative 16. Our b value is here, 32. Our c value is here, 9. Our c value is actually our y-intercept. So this actually looks something like this. And it starts at 9 feet because I probably am a human being who is maybe 5 feet or so tall, and I throw my arm up above my head, and that's where I'm going to start instead of starting at the ground, because I didn't start the ball from the ground. I started the ball from overhead when I threw the ball. So that's why you're starting here at 9 feet. Okay, that's your y-intercept. All right, so let's do our vertex. Remember, max height, that's just the y value of your vertex. That's all that is, okay? So I just go negative b, so negative 32, over 2 times my a value, which is negative 16. Reduce this, right? 32 times negative 16 is negative 32. Negative 32 over negative 32 is negative 1. So that is going to be your time at, oh, excuse me, I just made a brain fart. And this is how I knew I made a brain fart. Because time isn't negative. That's weird. I can't go back in time. Time has to be positive. So 32, negative 32 divided by negative 32 is positive 1. So I apologize for that. All right, positive 1. So what is the actual height? That's my time. What's the height? Well, remember, I just plug it into my equation to get my height. So height is negative 16 times, I plug in negative 1 for time. I just did that again. I apologize. I positive 1 for time squared plus 32 times 1 squared plus 9. Well, negative 16 times 1 is negative 16. 32 times 1 is 32 plus 9. So negative 16 plus 32 is 16. 16 plus 9, what is that? 35? 25? I can count. 25. At 1 second, so if I go over, if this is 1 second, maybe this is 2 seconds. If I go over 1 second, I get a height of 25. So what is the max height? How long does it take the ball to reach there? It takes the ball 1 second to reach its max height of 25 feet. Okay, so 1 second. What is the ball's max height? 25 feet. So when they want to know how long it takes to reach the max height, that's the x value of your vertex, that's 1 second. When they want to know what it is the y value of your vertex. So really what they're asking you for, how long does it take to reach the max height? What is the max height? They just say, what's the x and y value of the vertex? If I said that to you, you'd be like, oh, vertex, negative b over 2a, and then I plug that in to get the y value of the negative b over 2a. That's all it is. That's how long it takes. That's what it means. So apply the vertex to an actual problem, and this is what you're asking. Okay? And that makes sense. It's only going to take a second because the ball's going to go up and it's going to come right back down real fast, right? If you can throw it 25 feet in the air, that's pretty tall. Okay, so that's 22. And what's our next request? 26?
Yes.
Okay, let's go to 26. Okay, what is the c value such that x squared plus 6x plus c is a perfect square trinomial? So this is asking you, do you know how to complete the square? Do you know the basics of completing the square? Completing the square is where we're trying to, once again, put this into something, plus something squared. And we do that because it's something plus, so it's like x plus c times x plus c, okay? And we want it to be squared, right? That's what we'd like. I see that, Nolan. I'll do 25 next, okay? Let's go ahead and look at this. To get the perfect square trinomial, what I do is I take my middle term, I divide it by 2, and I square it. So if I have x squared, let's do ax squared plus bx plus c. I can't find my perfect square trinomial if I have an a value. The first thing I would have to do is divide out the a value. Once I do that, I divide both sides, or I factor it out and leave it on one side. Okay, once I factor that out, to find your perfect square trinomial, you take your middle term b, you divide it by 2, and then you're going to square that value and add it to both sides. Okay, or you're going to, if you're not dealing with both sides, you add it to one side and you subtract it from the same side. Okay, So I take my middle term, 6, I divide by 2, and I get 3. And then I square that term. 3 squared is 9. 9 is going to make this a perfect square trinomial. So how do you make a perfect square trinomial? You take your middle term, you divide by 2, and you square it. Then you add it to both sides. Make sure you know how to do that.
Okay.
All right, let's do number 25 because Nolan wanted to backtrack for a second. Let's backtrack to 25. Complete the following sentence. You can verify the zeros of a function by using a graph and finding where the graph what? All right. You wanted me to wait for something? I just saw that in the checkbox. Okay. Okay, Haley, where did I get the 9 at the end? To find a perfect trinomial, take your b, divide it by 2, and square it. So take 6, divide it by 2. What do you get? Yep. Take 6 and divide it. You get 3. Now square 3. Yep. B squared divided by 2, or b divided by 2 squared is what c should be. That will make you have a perfect square trinomial. And that only works as long as there's not an a value here. If there's an a value here, you first divide out the a value or factor out the a value. Then you take your middle term and divide it by 2 and square it. That's what that term has to be. B divided by 2 squared. And then once it is 9, so it is 9. So what if I were to write this as a perfect square trinomial, it then would write like this. It would be x plus 3 times x plus 3. And if you multiply this out, 3 times 3 will give you 9. So x squared plus 6x plus 9 makes this be a perfect square trinomial, and it factors into x plus 3 times x plus 3, or x plus 3 squared. That's what I wanted it to be, a perfect square trinomial, so that I could perform some operation on it where I square root it, or I put it in vertex form. That's why we do that, so that I can see what the vertex of the parabola is. That's the whole point of making a perfect square trinomial. You manipulate it to be how you want it to be. Okay, let's go back to this, finding the zeros of a function. Find the zeros of a function. Well, zeros. Let's look at x and y. When I find the zeros of a function, let's say I were to graph a parabola like this. Where are my zeros? Where are my solutions? Usually I look for the solutions. What are the solutions? When I'm looking for my zeros, I'm looking for these points here, right? So what I usually do is I say, I set this y equals to, if I were to solve this, 0 equals x squared plus 6x minus 7. And I ask you to solve this. What you're going to do for me is you're going to graph this equation, y equals to x squared plus 6x minus 7. Okay. And then you're going to tell me, where is y 0? Well, y is 0 when it touches the x-axis. Those are the zeros of the function. So if I ask you to solve this by graphing, you graph the related equation. You're actually graphing y. You can't graph this because there's no y value. You just want to know when this is 0. So you graph a related equation. I'm going to just mute you for a second. You're going to graph a related equation, y equals to this, and then you look where y is 0. Y is 0, not up here. This is where y is 1, 2, 3. Y is 0 down here, where it touches the x-axis. So you can verify zeros of a function by using a graph and finding where the graph touches the y-axis. Excuse me, x-axis. Well, that was a big brain fart. Touches the x-axis. Okay? That's where y is 0. It touches the x-axis, or it crosses the x-axis. That's how you find the zeros of the function. That's where y is 0 on the x-axis. Does that make sense? Okay. All right, let's go over, we want to do 26, oh, and 40. We want to do 40 next? Okay, let's go to 40 and make sure we cover that one. Okay, use the lines from the random number table to randomly select 3 people from a group of 16. Okay, you have 3 people you're selecting. You have a group of 16 people, so possibly you could group these how? How would I group these? By 2, right? Because there's 16 choices, right? Because there's a group of 16, you're going to group by 2. Because what you're going to do is you're going to number off, like you're number 1, you're number 2, you're number 3. But when you get to number 10, 11, 12, those are, the 10, 11, and 12s are groups of 2. So you have to be able to hit two people if you're numbering them off, right? I mean 2 numbers. If you're numbering people off, like I'm number 12. I want her to pick number 12 because that's me. I'm number 12. I want her to pick number 12. Well, I have to group by 2s. So what I'm going to do is I'm going to group this 81, then 02, then 16, then 95, then 07, then 75, 93, 59, 38, 03, 27, 76, and then 4 gets to be out there by itself, okay? So I would like to select randomly 3 people from a group of 16. So I want numbers 1 through 16. So I'm going to pick the first 3 numbers that I can find between 1 and 16. Okay, so 81, that's not between 1 and 16. Nope. 02, that's the number 2. So there's my first choice. 2 got picked from this random number table. Good. 16, ooh, that gets picked. That is number 16. Okay, that's my next one. 95, no, that's not between 1 and 16. 07, ooh, 7. 7 is between 1 and 16. There are the first 3 numbers that randomly get picked. Yeah, they're easy once you get the hang of it. So here's the key. The random number, it's just numbers on a table. So this is how a computer will randomly pick numbers, right? It randomly generates numbers, and then if you're picking selective, I want to pick 3 random numbers, but they have to be between 1 and 16. You have to pick a pairing. Like if I said between 1 and 9, you would only pair them off by 1s. But because it's 1 and 16, you need a double digits. So you have to pair off by 2s. Okay? And you do hit those lower numbers because when you have a 0 in front, that gives you that lower number. 02 is 2. All right? Yeah, they're kind of fun to pick them out like that. So you have to go by the grouping of your largest grouping. So you have to group by pairs of 2. And then you go ahead and pick out the first 3 numbers that fall in this category. So first group them by your largest grouping, and then go ahead and pick out the first 3 numbers. So not that one, but this one. And this one. Not that one, but this one. And if you go on, if it said pick the first 4 numbers, you could go on and pick another one. So it wouldn't be 75 or 93 or 59 or 38. 3 would be your next one. Not 27, not 76, and then this, there's no more numbers, so I would be done. I would need more numbers to pick more. So, all right, so that's how you do it. Group it by the largest grouping that you need, and then go through and pick out, make sure it's in the category you want. Make sure it falls in your range throughout the ones that don't. Okay, those are the requests that you gave me so far. Are there any others that you want to go over, guys? I can do a couple more if there's any others that you'd really like to go over. Okay, 27. Okay, model rocket launched from a roof into a large field. So here's another rocket problem. It's kind of like our ball where we threw it up, right? Okay, the path of the rocket can be modeled by the equation. So they give us that equation, where x is the horizontal distance in meters from the starting point on the roof and y is the height in meters of the rocket from the ground. How far horizontally from the starting point does the rocket land? Guys, always good to draw yourself a little picture, okay? So I'm going to give myself a little axis, axes, not access. Nope, axes. I'm going to give myself a little axes. Okay, if I'm launching a rocket from a roof, I'm not going to be launching it from from the ground, from a roof. So I'm up here, okay? My rocket's going to go up and come back down, right? This is what I'm looking at. The horizontal distance, x, is in meters. The height, y, is in meters too, okay? We want to know the horizontal distance. So the hard part about this is, what am I looking for? Remember when we wanted to know, what is the maximum height? How long does it take to get to the maximum height? Oh, max height means vertex, y value of the vertex. How long does it take to get there? That's the x value of the vertex. Okay, that's not what it asked us here. It said from the starting point on the roof, how far horizontally from its starting point will the rocket land? They want to know the end point. How far from the starting point will it land? They want to know the x value of this point here. So figure out what they want. It's asking distance from start to finish. It's just asking for this point. Where does it cross the y-axis? They want to know where y is 0. That's what they want to know. So this is asking me, what is this point? Where is y 0? I want to know this point. Where's y 0? Set y equal to 0 and solve. 0 equals negative 0.04 x squared plus 9.9x plus 5.6. So drawing this picture helped me realize what they were asking me. Drawing that other picture helped me realize, oh, they were just asking me for the vertex. That's the max height. Here they're asking me, how far from the starting point will the rocket land? They're asking me for the landing point. That's here. That means I have x, comma, some 0 point for y. I want to know when y is 0, so I got to know this distance. Now, granted, an actual parabola, if it were going, would actually be like this, and it would have another point here, right? It would be a negative point. I mean, I kind of drew that weird, but I'm just sketching the graph. I'm not sketching an exact graph. An exact sketch would be good. I could plug this in on Desmos and see what it looks like, okay? But somewhere over here. So when I solve this, I actually will have two zeros. I'll have a negative 0. So this would be some negative x point, comma 0. And I'll have my positive. I don't care about this negative point. It's not going to tell me anything because I actually started here. But my actual parabola will curve down like this. And this is really not very pretty. Is that better? Let's do it like that. This is my ugly pieces. Okay, so just for the logic of it, draw yourself a picture, figure out what they want. Oh, they just want to know this point. They want to know when y is 0. Solve. Now, how do I solve this? If I'm not graphing it, if I don't have a graphing calculator or Desmos on the test, how am I solving this? Well, quadratic formula. Make sure you know, okay? Negative b, isn't it where x is 0? Haley, it's not where x is 0, it's where y is 0, right? This would be, I'm going over on the x this far, and I'm going up nowhere. I'm not going up at all. So I get an x point, and I get 0. The y goes up and down because I'm not going up. The y is 0, okay? The x is a point, the y is 0. So we plug in 0 for y. Let's do quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Make sure you know quadratic formula. X equals. This is what x equals in the quadratic formula. Okay. So here, let's write up here. Our a value is negative 0.04. Okay, our B value is 9.9 and our C value is 5.6. Plug it in. So we're going to go negative 9.9 plus or minus the square root of B squared. Let's just plug that in. 9.9 squared. Let's do that right away. It's 98.1. So 98.01, excuse me. That's what 9.9 squared is. That's my B squared. Minus 4 times A times C. Let's do that right away. So negative 4 times A. So I'm going to go 4 times 0.04 on my calculator. Since they're both negative, that's going to give me positive. So I'm going to plug this in here and this in here. Okay, so I go negative 4 times negative 0.04 times 5.6. So that is going to give me positive 0.896. Okay, so just plug that all in. All over 2 times my A value, 2 times A, so 2 times this. 2 times 0.04, and it is negative here. So I'm going to have negative 0.08 on the denominator. Now add this together. 98.01 plus 0.896. Now these are ugly numbers, but they're real. Okay, so this inside here, I'm going to write over it in blue. This inside here is actually 98.906 when I add that together. Okay, so I'm square rooting 98.906. I'm going to square root that. So second square root 98.906, and that's going to give me this part in here. I'm going to round. So I'm going to end up with negative 9.9 plus or minus, after I square root this, I get about 9.9. So I'm going to give about 9.9 and maybe 9.945 or 9.95 maybe. Not a point there, sorry, there's no point there. 9.95 divided by negative 0.08. So you have two problems. Negative 9.9 plus 9.95 divided by this. Negative 9.9 minus 9.95 divided by this. Let's do the first one. If I do negative 9.9 plus 9.95, so if I do 9.9 plus negative 9.9, so you're subtracting those two. This is going to give me negative 0.05 divided by negative 0.08. So go ahead and do these two, divide these. If I did, actually, I'm sorry, negative 9.9 plus 9.95 will give me positive this divided by negative this. I apologize. Okay, so this is going to end up with being negative 0.625. So this is my negative point right here. This is negative 0.625, comma 0. That's my negative point. And then here's my positive point. So let's go. Negative 9.9 minus 9.95. So 9.9 minus 9.95. So they're both negative, so they end up being a bigger negative. So this is going to give me negative 19.85 divided by negative 0.08. So a negative divided by negative is going to give you a positive. So this is going to give me approximately 248.125. So this point over here is going to be the x point 248, and you could round to the nearest tenth. So let's go 248.2, comma 0. Now this point I don't care about because I didn't actually launch from 0. I launched from up here. I don't care about my negative point. I want to know the distance from the start to the end. It ends 248.2 feet away from where I started. This is my answer. All right. That's how you do that. It really isn't hard conceptually. It's tedious with the math, but conceptually it's not hard. Okay, all of this little nitty-gritty can get tedious if you make a little error, and all of this nitty gritty can get tedious if you make a little error. But if you draw it, really what you want is just this point. You want to know when y is 0. You come over here and you make y equal to 0, and then you use quadratic formula. X equals negative b plus or minus all of this. You're just using quadratic formula to solve that problem. Okay, other questions? You see what you did here? I can hear you typing, Ileana. Do you just want to say it?
Sure.
You're good? All right. If you're good, you can go ahead and log off. Good luck. I'll be at the finals on Wednesday. Ileana, did you have another question? I'll stay on and answer another question if you have another one. Of course, I'm always open for emails, guys. And oh, here's another. Of course, Haley. Here's another reminder. Thursday, I have another tutoring session. It's open for everyone on Thursday. So if you're going through these again and you're still kind of stuck, come on Thursday at 11. I'm back on Thursday at 11 for open tutoring for all classes, just to wrap up more questions. So at 10, I'm doing a Math 3 tutoring session. So come at 11. It's open for everyone. All right? Yes, Thursday at 11. I'll have another session. All right, guys. Good luck. Okay.